Everyone, welcome back. In this video we're going to talk about formwork for beams and slab. Now when it comes to beams, it's important to understand that beam and slab, we have similar, their formwork, not ground floor, their formwork will be erected together. So the beam, this is not the one that we're looking for. Now for the floor system that we have beam and slab. Now we have different type of flooring system. You might have one-way slab, two-way slab, with beam, without beam, waffle slab, one-way ribbed slab, flat plate, different type of flooring system we have it. The idea is what? To know exactly what will be the formwork. So some of them are straight, some of them they have beam with it. So how do we create this? Look at this one here. You realize that those are the beams, the places that you can see it here. Those are the beams. And this is where the slab basically comes. Because we said that both of them will be casted together. So the beam and the slab will be casted together. Now, in order to understand this one, we need to look at the beam formwork. For the beam formwork, you're supposed to understand that this is not ground beam. This is not ground beam. So we have formwork on the three side. Three with the bottom and two side of it. Look if you can see it here. We have formwork here. We have at the bottom, basically the two sides and the bottom. Now you realize that this formwork comes from where? This is the slab. Look, start from the slab to the bottom of the beam. Now why this is going to help me? Because if I come to AutoCAD, if you want to calculate, so I'm just going to show it over this section here. When we want to calculate a formwork, let me just do it here for you in order to understand. There will be formwork here. There will be at the bottom of this beam. There will be this corner, and here it's for the slab. So realize that for the beam I have it 1, 2, 3. So the bottom, the two side. Wow. Let's check something which is interior. Doesn't matter, yes. Even if you have wall under the beams, remember the beams will be cast, then the wall will be created, placed. Now I'm not talking about if you don't have column. In some system you don't have column, they just have a wall. Yes, they will create the wall first, then they will put the formwork for the beam. In that case you don't have the bottom of the beam. Yeah, in small house they will build the wall, then the beam will come over the wall. Like the beam will come over the wall. So in that case you only have the two sides of it. But here, since you have a column beam system, then you have the three side as well. So the bottom and the two sides. Now look at it, those two will be similar depending on the thickness of these slabs. Another one that I want to show to you here, when we have two different slabs around the beam. Look at here, this slab is 12, this one here is 15. This is 15, it's not shown. So what we have here, when we're trying to find the formwork for this beam, this side is a bit shorter than this side. You have three, you have to calculate them. Remember, the bottom of the slab will be the top. You don't have it. The top you don't have it. Why? Because you place concrete in this way. So you only do the bottoms and the edge of the beams. Now sometime the beams here, the slab continues. So you have to know exactly if the slab is continuous or not. Why? Because if the slab continues, the outside of the beam with the inside will be similar. Like for example, if the slab is continuous, will be something like this. Those two sides will be equal height. If not, the outer side will be more than the inside. The height of the outside of the beam will be more than inside of the beam. Well, let's do some calculation to see how we do formwork. So we'll take one of the beams. So I'm choosing a beam which is in between two slabs. We'll have two types of beam we'll cover. Let's just cover one which is outside first, then inside. Now we have, when we're talking about beam, we have exterior beam, interior beam. When I say outside and inside, exterior beams, the beams are around the perimeter. We call them exterior beams, and interior is the one inside. Now for the first floor, for the second floor, we have different. For example, look at here the slab does not continue, but for the second floor you see the slab continues. So those will be considered as interior as well. I can consider them as interior, but they are exterior. And by the way that we tell that for formwork, we call them exterior, interior, because of what? Because of the edges here. Because this side is a bit high, or like deeper than this side here. Let's take one of the column, K102. This is one of the beams that we want to calculate the formwork for it. Now we know this beam is 25 by 60. 25 by 60. Well, the 25 is the bottom and 60 is the height of the beam. 60 is the height of the beam. Now, since this is exterior beam and the slab does not continuous, so we have this case here. This is the case we have it, since the slab does not continue. Now where does the formwork will be? Now pay attention here. This is the inside formwork, yes, the horizontal column. What about outside? Outside supposed to be something like this, yes? Because formwork is a continuous, you cannot leave any space, yes? It has to be like this. And the other one will be like this. This will continue in this manner. From here will come like this. Look, what I'm doing it, I'll provide formwork around the side of the beams. Remember the side of the beams, we have it. Look, I'm just trying to put the side of the beam. Look, the side of the beam comes, this is, oh, this columns here, this is wrong. Let's check something which is yes, here. Realize that the out should come over the column. It has to come, because this part of the column is not being cast, so it will cast with the beam. So in this manner, you have to make sure you have a continuous line for you have a lot of pictures to look. For example, look at them, they continue in this manner in order to understand what you're doing. Now, in order to make our life easier here, now where do I take this part of the column, to this one, to that one? Well, you have to manage this one differently. So what I will show you here, I will make this one the inside. I will use the same length for the outside. I can add this part as extra. I can add, for example, this one, half of it to this side, or maybe I can even add this one to this part. Now those are supposed to be, the formwork supposed to continue. This is for the side. You can add those an extra, or you can just put them together. So for the outside, I can use this length. For the inside, I'll use this length. Now imagine that this is not available. This will be the calculation we have it is. We'll take this for the outside and this is for the inside. Well, let's write it here. So I'm writing this beam to see how we're doing it here. So we have beam, we'll write it K102. Now I'll write what? Interior side. And I have another one K102 that will be exterior side of it. Exterior side. I have two sides here. I'll talk about the bottom as well. But first, now for the interior side, we have one. Now the length of the interior side, we'll take it from here, which we can see from inside to inside is 240. We'll bring that value here. So we have 2.4. Then this is interior side, yes. We want to calculate the height of the formwork. The height of the formwork will be this. Like, it will not be 60 for the beam because it's interior and you have slab here. Due to the slab, you take the slab thickness out of it. So whatever the slab thickness, we can see it from here. Look, you're not supposed to look at this one here. Look at the slab which we have it here. But the idea is what? You take the slab thickness. This will be the remaining for the inside or interior or inside formwork. Now the slab here is 12. Remember, the slab here is 12 and the beam is 60. So 60 minus 12 will be 48 for the inside part. So write 48, which basically come from 60 minus 12. Here, if this slab is 15 and this is 60, 60 minus 15 will be 45 the inside it. But this is not for this beam. Remember, this is for another place. So this is how I found the inside or interior side. Now for the exterior side, I still have one. Now the length of it, I will add these two columns to it. Those two columns, I know that they are 25. So this will be column and this column. Extra, I have 25 here centimeter, and I have here 25 centimeter. So 50 centimeter, I will add it to the 240, which will be 2.9. 2.9. I can write 2.4 and add an extra here. That's also possible. You can do that one. 2.9, but I recommend you to know what you're doing. 2.9. Now the height of it here, since this is exterior beam and the slab does not continue, so we will take it like this. This is the height of the formwork, which will be the height of the beam, 60. Now let me tell you something. Some people, they will use the same thing, 0.48. They will use the same thing. Later, what they will do, so the idea that they are using it, and instead of separating outside inside, they will calculate it multiplied by 2, by the way, and they will add some extra to it if they have the same length. Then at the end, they will calculate the perimeter of the slab for this small distance, the perimeter, around the perimeter. They will calculate it as one element, which I don't recommend it. So for this course, when you're calculating formwork for the beam, I need you to follow, for the answers to be similar, we will take it as one formwork here like this. So this will be the height of the beam, which we have, it is 60. And for the outside, we're gonna write 0.6 here. Now comes for where? For the bottom of it. So K102, I have bottom of the beam. Now when talking about the bottom of the beam, it comes from the face of the column to the face of column. Please remember this one. It comes from the face to face of the column. Why? Because this side here is supposed to be empty. There's not supposed to be any formwork, because there is a reinforcement for column that will the steel reinforcement connect them together, and you will pour concrete inside here. We'll take another beam, it will be clear what we mean by that one. So when we're doing formwork for the bottom of the beam, you consider it from face to face of the column. This will be the bottom of the beam. Look at here. For this one, for the bottom, we'll do it like this. This will be the bottom reinforcement, bottom formwork. For the side, we know that this will be one of them like this. The other one will be from here, goes, even you can add this column to it if you want. So look at them. Those are, this is for the outside, this is for the inside, but here till here is the bottom. Remember the bottom from face of the column to face of the column. If there is no column, it's basically continuous. There is no column, it continues. Remember. Sometime look at here. This connection here. Yeah, if you think of the side of it, let's say I'm considering the side will be like this, and supposed to go till the end of it. This is the side. This is for still will be inside here. The other side of it will be like this. Now when we do the bottom, so if you do this one till here, remember the other one supposed to be from here till the face of the column. Remember this is for the bottom of the beam. Why? Because those are not ground beam. Remember, those are first floor beams. So the bottom you have it. If you remember, I told you for the ground beams they does not have the bottom side, they only have the sides. So if you have ground beam, you just consider them as a beam, just you put formwork around them, the side. But for the normal beams, which is first floor beams, second floor beams, you have the bottom as well. So for the case that we have it here, K102, we know that the bottom will be 2.4. So we have one, the length of it will be 2.4. What about the width of it, or the, here you can call the width rather than the height, will be the width of the beam, 25, because you cover the bottom of this beam, and this beam is 25 centimeter width, so I can write here 0.25. This is how you calculate the formwork for a beam. Let's take another beam, say for somewhere which is interior. Doesn't matter, the interiors might be easier to do. Let me choose something easy. Okay. I think I'll do one of them which will be easy. Okay, let's do this one. For the interiors, what we have to know? Well, let's say K205. You have K205 here. First thing, we will provide the side, like it comes up to here, and this one you can consider it from here, or you can even take it from this point till here. It can be like this. Well, this is a column here, there is no any other beam that is supposed to be with this one. Then we have the bottom of it. The bottom still gonna be face column to face of column. Now the interiors that we have it, what we have to check for the interiors, what we have to know for the interiors, you have to check the two slab beside the beam. Now this beam, there is a slab here and there is a slab here. This slab is 12 centimeter, this is 12 centimeter, so it means that the two sides of the beam, they have the same height, because 60 minus 12, other side 12, will be 48 for the two side. But if you have something different, well, which I prefer to go for the different one. I think we have one here which is between the two sides. Yes, here. K113. Now K113 is interior beam. Interior beam. Now let's say this is one edge of it. This is the other edge that you have it. But the difference is what? This side is 15 centimeter. The slab here is 12 centimeter. So when you're calculating the height for this side, you will say 60 minus 12. For the other side, you will say 60 minus 15. That's how you treat the interior beams. The exterior, the edge of it, if there is no continuous beam, no continuous slab, you take it as the height of the beam. But if the slab is continuous, you still treat them as an interior beam, which you can see it from the second floor. Look at here. Even though this, for example, K211, which is the exterior beam, or K203 exterior beam, but because the slab continues, the slab continues out, so that the two sides of it will be treated as interior. Based on what? This side and this side height will be depend on the thickness of the slab from the two sides. Still the bottom, still similar from face of column to face of the column. This is how you treat formwork for a beam. Let's do another one. That let's take something which is a bit hard. Let's come here. K206. Taking K206 as one of the cases. Now, here, what we have? One here, one side here, and one here. Yes, the bottom as well. So the bottom of it I can consider it till here. This will be the bottom of it. Now we need this length. We need to calculate, find this length here, how much it is. Then we can take care of this. Look here, we have to take care of this extra part here, which if you take this length, you'll take this one out of it. What do I need? I need to know the slabs to see the dimension of the slabs here, the thickness of the slab. Well, how many slabs do I have it here? 3 slabs, yes. Now where are the 3 slabs? There's one slab here, one will be here, one is here. 3 slabs we have it. Remember, this is a slab between the beams. A slab like this. There's a slab here, and there's a slab here. So this beam are linked to 3 slabs. Well, luckily all of them are 12 centimeter, so you don't have any problem with the height of the formwork. All of them will be the same, which we have 70 minus 12, so we have 50. So 70 is the height of the beam minus 12, the thickness of all the slab the same. That's going to be 58. We'll use it for the height of the formwork, for the side, remember, for the side. So we'll zoom in. We need to calculate this. We need to find the dimension, which will be provided to us by someone. So this is starting from here till here is 240. From here till here is 115, and this distance is 25. So I can add them all. I'll get from here till here. Now in one side, both sides they have the same height. Yes, both sides they have the same height. I just need to take care of this small distance here. Look what I'm doing here. I will do it at once. I'll write this one K206. I mean 2 sides. 2 sides of it, I will just write it together. Write it together. Look, I'll multiply this 1. I can do 2, sorry, 2, because 2 sides I have it here. Now the length of it, I will do what? I have 240, so 2.4 plus 0.25 plus 1.15. This is here, which is 3.8. I'll multiply it by 2 years, but I have something extra which I'll take care of it later. Now, the height of it, which we calculated 70, is the height of the beam minus the thickness of the slabs. 3 slabs, there are 12, so both sides they have the same height, which became 58.58. Now when I multiply those two together, multiply them, I'll get what? This meter square, remember this is meter square, formwork for the two sides. But we know that we took something extra, which is this one here, yes? 25 times 0.58, we took it extra. So I need to take care of this distance here, which I can write it as a minus side. In the minus side here, I can say equal to, this is minus 0.25 times 0.58. Remember, this is imagined as what? Imagine you took like this, which you should have not taken this space. Remember, like this, the beam gonna continue like this way. So this extra, it's what? It's 25, and since we already know this one, 58, so this area I'm taking out of the main area. That's why we'll say like this, and we're calculating this one, we'll say plus this guy here, which is the minus, and it will be taken care of. Like easier, I can manage two sides together. Why? Because they had the same height. If they were different height, sure, I had to separate them. For example, side 1, side 2, in order to take care of them. Well, what else remain here? The bottom of it, sure, KO2, the bottom we have it, which is the easiest part here. So the bottom of it will have 1, will be the same 3.8, yes, 3.8, because what we did here from face of the column, we'll bring it till face of the beam. This is the other beam here, will be considered for the next beam. You're not going to bring this one till here because there's another beam here, which is the bottom of it. So it's going to be 3.8, and the width of the beam is 30 here, so that will be the width of the beam here, 0.3. And you have the bottom formwork as well. So in this manner you will do all the beams and you will get the formwork. Now let me show you for slab, which is the easiest formwork that you can have it, the same video. In order to calculate the formwork for the slab, what will you do? You'll just take interior of the beams here. That's it. You already took care of the beams, so where will remain here, you have an area which is, you have to put a formwork, yes, a wood right here, exactly right here. This is an area you put a formwork in order for the slab to be cast. So you take the area of the slab. That's the easiest formwork that you can calculate is for the slab. You calculate the area of the slab here. Now if I can show it to you, which one is for the let's see if it's gonna come out. In the beginning of them, you saw that there will be to put the formwork slab only. Remember, under the slab, the edge of the slab will be taken care of and have continuous slab. So it's gonna be clear. Those are with the beams, but the slabs kind of not clear exactly. Yeah, this is kind of will be something like this. You have a sheet, plywood will be placed in this manner. So this will be the bottom of the slab. You only cover the bottom of the slab here. Remember this. This will be the formwork for the slab. So in the case which we have it here, we already took care of the edge. We only need to cover the area. So if I want to write down for one of them, for example, D102, 102, what I have one of them. We'll just take the dimension, nothing more. Now this is a rectangular 240 by 280 interior dimension. That will be the slab we have it there, 2.8 and 2.4. Remember, it will be meter square, and that's going to give us the area of the formwork for this slab. Remember, under it. Now, if you remember for the second floor, yeah, where do we talk about when we calculate this formwork? We talk about we only put slab here. Remember, we only put formwork here. Now this part which is extra you have it there, you will treat it the same way. You will put the formwork under here, and then you will put the formwork at this part here. Now in order to calculate this one here, which is the small part here, this one, you have to take care as what? From the plan. Now you will consider this one as the area. Look, you calculate this area. You calculate this area around, this is extra, 20 centimeter will go out. You calculate this one. This is the area, which basically you put what? You put formwork under it. You put formwork under it. That's why you calculate only area of the slab. That's why it's easy to calculate formwork for slab. You just need to calculate the area. Like if it is interior, let's say you have an interior slab, doesn't matter. Anywhere you have slab, you still can calculate the area. Let's say it's not a rectangle, yes, you can still calculate the area. Like for example, with something like this. Or you can calculate the area in this manner. You can divide it into two part, area 1, area 2. But still you're calculating the area of the slab, under the slab. For example, this, which I did them here, those are where? Under the slab here. Now for the edge of this one, what you have to do, you'll take the perimeter, of this plan. Because you have something that's gonna go around, yes, something like this. Imagine you have something like this. So when you're providing this formwork, it will be somewhere around as well. Come around. This is for the edge of it. For the edge of it will be around the plan, which is the easiest part for the formwork. We have it here. Now for the staircase, I'm not going to go into in detail of staircase because we have many type of staircase round, but for the bottom of the staircase is like a slab. You take the area of it. But for the edge of it, it depends on the country that you're working. In some places, they took it as a meter long because of the steps. For the formwork for staircase, it's a bit different. So I'm not going to go into detail of formwork for the stair. That will be enough to know for foundation, beams, ground beams, columns, and slab. Thanks for watching.